Okay, today we're going to learn how to be able to find an equation of a line from a graph using different methods. That's the first thing. And the second thing that we're going to learn today also is about perpendicular lines and parallel lines. What's common between them and what's not common between them. So, okay, let's have a look at this example. Finding the equation of a line from the y-intercept and another point. So if you look at the graph that's been given there, according to the graph, we can find 2 points. That point, the y-intercept, is 0, -4, and then the x-intercept is -2, 0. Okay, now that being the y-intercept, we can state immediately that c is equal to 4. From the 2 points, another thing we can identify is the gradient. Now we know that equation of a line is in the form of y equals mx plus c, where m and c are the two things where you will have numbers. C we found already, which is the y-intercept. Now we know that gradient is equal to rise over run. According to this graph over here, if we start from the from the most left point, and we go in the y direction, rise, so we have to go down 4 places because we're going down. The rise is -4, and then run, which is across. We have to go across to the right 2 places because it's right, it's 2, and that gives us -2. So we found our gradient, we found our y-intercept, and if we put them together in the equation in the form of y equals mx plus c, m is -2, x plus 4. So that gives us the equation. Whoopsies. Let's fix that. That gives us the equation of the line. And that's by using our y-intercept and by working out the gradient. This is just continuing from what we learned yesterday. Okay, let's have a look at the second example. Find the equation of a line from the gradient and a point. So this information tells us that it has a gradient of 3 and it's passing through the point 1, 8. So let's write that down. Let's write down information that we know already. So m equals 3, and it's with the point of 1, 8. Let's now substitute this in an equation, the equation of the line, which is y equals mx plus c, and let's see if we can work out c. So the y value, according to the point, is 8. Our gradient is 3 times by our x, which is 1, plus c. So that means 3 plus c is equal to 8. To work out what c is, we take away 3 on both sides, take away 3, and that cancels off, and we have c is equal to 5. So now if we put that in an equation, y equals mx plus c, we know the gradient was 3, so we have y equals 3x, and we worked out our c to be 5 plus 5, and that gives us the equation of the line. Okay, moving on. Perpendicular and parallel lines. Now, as we discussed, when lines are at an angle, obviously it's got a slope. If you have a parallel line, if you look at the green and the blue line, they have the same slope. So any line that are parallel, they have the same gradient. So that's something that we need to remember. If they are parallel, that means they've got the same gradient because they have the same slope. If you have a look, it's slanting up at the same angle to the horizontal. It's the same angle. But if you have a look at this line, now have a look at this line. This is perpendicular, the red one. That is perpendicular. Do you think it'll have the same gradient? No. Firstly, it's also facing the opposite direction. So if it's facing in the opposite direction, so the blue and the green, or purple and the green, that's a positive gradient line. Look at the red, opposite, negative gradient line. So that's the first thing that we need to identify, that it's got a negative gradient. And the rule is that if two lines are perpendicular, the two gradients then multiply to give us -1. So just to rewrite that, the gradient of the first line, so line 1, M1, multiplied by the gradient of the second line, M2, it gives us -1. So say, for example, if we know if M1 is equal to, so look at the example over here. If you look at the green line, okay, let's say this is the first line. It's the first line, and the gradient is equal to 2. Then M1 times by M2 gives us -1. So M1 was 2 times by M2 gives us -1. To find what M2 is, we divide both sides by 2, and what we get is M2 is equal to -1/2. So if ever you were given the gradient of a line, then you can find the gradient of the parallel line as that it being the same. You can find the gradient of the perpendicular line by using this rule. M1 times M2 is equal to -1. Okay, let's have a look at a demo. So I'm going to come back at a demo on Desmos. So we'll look at a demo on Desmos in class. We'll look at that in class. Okay, but let's do a couple of examples. Right, find the equation of a line which is parallel to the line y equals 3x minus 1 and passes through 0, 4. So because it's parallel means it's parallel. So we know if it's parallel, that means gradient 1 is equal to gradient 2. Okay, so this is the first line. Let's say this is line 1. Okay, so for line 2, because M1 is equal to M2, this tells us that the gradient of that line is the same as the first one, which is 3. Because if you have a look from the equation, that's our gradient. That's equal to 3. To work out what the equation is, then we'll do what we've done before, what we've done up here in that example. So let's go back and do that. Okay, right, so the points is 0, 4. Let's substitute that in the equation. Y equals mx plus c. Y is 4, that is equal to 3x, x is 3 times 0 plus c. 3 times 0 is 0, so c is equal to 4. So that gives us the equation as y equals 3x plus 4. And that's the equation of line 2. Now, when it's perpendicular, it's slightly different, because first we have to work out what the gradient is. So for line 2, so you find the gradient first using M1 times M2 equals -1. So the gradient for line 1 is 2 multiplied by the second line, which we have to find, is equal to -1. To find out the gradient of the second line, we divide by 2, and that gives us M2 equals -1/2. And then again we use the same method and substitute these points into the equation. Y equals mx plus c. Y is -1 equals gradient is -1/2 times x is 0 plus c. Negative half times 0 gives us 0, so c is equal to negative 1. So therefore, equation of line 2 is y, just substitute everything, y equals negative half x take away 1, because we've just seen that the gradient is negative half and c is 1. Likewise, I'm just going to highlight it over here as well. Gradient over there is 3 and our c is 4. Okay, we'll do some exercises in class and see how we go.